This example asks us to give equations of any vertical, horizontal, or finally oblique asymptotes. So let's go ahead and look at our example A here. In this case, let's figure out what our vertical asymptote is. So in other words, let's go ahead and set that bottom equal to 0 and solve for x. So this is going to go ahead and be our vertical asymptote. So setting our bottom equal to 0 and then solving for x, let's see what we get. So we want to go ahead and try to factor this one out. So we need two numbers that multiply to -6 and added or subtracted gets us -1. So in this case we will have an x minus 3 and then an x plus 2. Okay, and if we set both of these equal to 0, x should be equal to 3 and x should be equal to -2. So these are going to be our vertical asymptotes in this case. Now let's go ahead and check to see if there are any horizontal asymptotes. So horizontal asymptotes, let's go ahead and look at our rules up here. So in this example, it looks like we have the bottom 1 degree more than the top. So if the numerator has lesser degree than the denominator, then there's a horizontal asymptote of y is equal to 0. So this is, in our case, is what we need to do. So in other words, since our numerator (1 degree) less than denominator, we will go ahead and have a horizontal asymptote of y is equal to 0. Okay, and finally we want to go ahead and see if we have slanted asymptotes or oblique asymptotes, and that's going to go ahead and be this C portion here. So if the numerator is exactly 1 degree more than the denominator, there will be an oblique or slanted asymptote. That is not the case for us, so we will have none in this case. All right, let's go ahead and move on to B. So B, we're dealing with 4x minus 2 divided by x plus 1. Let's go ahead and figure out what our vertical asymptote is. So vertical asymptotes, we want to set that bottom equal to 0. So x plus 1 equal to 0, or in other words, x is equal to -1. And we are finished for our vertical asymptote. Now our horizontal asymptote, let's go ahead and see. Notice that the numerator and the denominator have same degree. So same degree for our numerator, or our top, and our denominator. So what did it say? Well, that's going to go ahead and be our second point here. So if the numerator and denominator have the same degree, then take the fraction of the leading coefficient. So let's see what that will give us. In part B, if we take the fraction of the leading coefficients, that will be a 4, and essentially this is multiplied by 1 out in front. So we have a 4 divided by 1. So y is equal to 4 divided by 1. Or just equal to 4. Okay, and again, we're not going to have any oblique / slanted asymptotes because the condition that we needed in order for that to occur was that the numerator is exactly 1 degree more than the denominator, which is not the case. So again, we will have no oblique / slanted asymptote. Okay, now we can go ahead and look at part C. So this one's going to be a little bit different than the previous ones, as we will now have an oblique / slanted asymptote. Okay, so first things first, we want to go ahead and look at our vertical asymptote here. So vertical asymptote, again, we want to set that bottom equal to 0 and solve for x. So x is equal to a +1, and we are finished with our vertical asymptotes. Now, looking at our horizontal asymptotes, we're going to go ahead and approach this a little bit differently because in this case, our top is 1 degree greater than our bottom. So let's go ahead and create some sort of method. So let's go ahead and divide everything by the common bottom. So our common bottom in this case is going to go ahead and be x squared. And we'll go ahead and take x divided by x squared, as well as our bottom divided by x squared. So that will give us an x divided by an x squared. And then we'll go ahead and subtract a 1 divided by an x squared. So this will simplify. An x squared divided by an x squared is a 1. Plus, we can cancel out an x from here, which will get us a 1 divided by x. And then we'll cancel another x out, so 1 divided by x. And we will minus 1 divided by x squared. Now the key with this is we want to observe as the absolute value increases, what would we have? So observe when, we'll say absolute value of x increases, or in other words, as we go to infinity. So let's see what happens. Well, 1 will stay the same, 1 plus, and 1 divided by, if we plug in infinity or as x increases, that's just going to be 1 divided by a really big number, or in this case, it will go to approximately 0. Okay, so we can go ahead and say about 0 for this one, divided by, and again we said 1 divided by x is going to go ahead and be that approximate 0. And the same thing is going to happen if we take 1 divided by, we'll say infinity squared. That's just going to be 1 divided by, again, a really big number, or in this case, approximately 0. So we can go ahead and take approximately 0 and subtract approximately 0. So that's going to get us a 1 divided by 0, which really doesn't make any sense, so we don't have any horizontal asymptote. Okay. Our last portion that we want to look at is the oblique asymptote. So oblique asymptote, if we go ahead and look at our original, we have 1 degree higher than the bottom, so we will indeed have oblique asymptotes in this case. So we'll go ahead and say, notice how the top has exactly 1 degree higher than the bottom. So in this case, if this happens, we will have oblique asymptotes. So oblique, and then we'll say asymptotes. Okay. So what we want to do, if we go ahead and look back up, we want to go ahead and if the numerator is exactly 1 degree more than the denominator, we're going to want to go ahead and divide the numerator by the denominator, and then set the rest of the quotient equal to y to obtain an equation. So let's go ahead and do that following step. Okay, so setting up our division, what will we have? Well, we'll have a 1 on the outside, and additionally we will have, let's go ahead and see what we need to do. So we will have a 1 on the outside, and the reason we have that, notice how we have an x minus 1, so we want to take the opposite sign. And then our coefficients will come from this x squared plus x. And then finally, we need to take care of the constant, so we'll add a placeholder for that. Okay, so doing so, we will be left with a 1, and then a 0 for that placeholder for our constant. So bring the 1 down, so that will give us a 1, and then continue to multiply and add the columns. So that will give us a 2, and then finally a 2. Now it said go ahead and set the resulting quotient equal to y. So we'll have a y is equal to, and we want to go ahead and take 1 degree less than our original. So we'll start with an x plus 2, and then finally plus, and then our remainder was 2, and then divided by x minus 1. Now, one thing we want to go ahead and note is as we go to infinity, what happens to this 2 divided by x minus 1? Well, as we approach large values, we'll say approach, and then large values, this will go to 0. So in other words, we can go ahead and ignore this portion since it will go to 0. So our oblique asymptote y is equal to x plus